Good evening, everyone. It gives me immense pleasure to welcome you all to the day 5 of our FDP. Over the last 4 days, we have explored incredible insights into modern power grids and renewable technologies. Thank you all for your remarkable consistency and engagement. Let's make today another day of immense learning and meaningful takeaways. On behalf of the organizing committee, I extend a warm welcome to all of you. Thank you. Today, we have the distinct privilege to welcoming a highly distinguished expert as our resource person to enlighten us on a crucial theme, energy efficiency for sustainable future. It is my honor to introduce Mr. Renjith PC. He is currently serving as the Project Executive Officer and Energy Auditor at KSCM IIT Kanpur. He is a BE certified energy manager and auditor with expertise in energy audits, energy efficiency, energy analysis, and energy management systems. He has experience as project manager, electrical maintenance engineer, academician, and trainer. With his extensive background, we are incredibly fortunate to have him to share his insights with us today. On behalf of the Triply Department and all the participants, I extend a heartfelt welcome to you, sir. We look forward to an incredibly enriching session. The platform is yours, sir.
Thank you. Thank you for the wonderful introduction. Once the voice is clear.
Yes, sir.
Okay. So once again, good evening to all the participants, and thank you for the introduction and also for the Sripati Institute of Management and Technology. So I am already introduced that one. Just I am Renjith PC, presently working in IIT Kanpur as a project officer as well as the energy auditor. So mainly concentrated in the energy audits in the industrial sector. So today we will discuss more about the energy efficiency, energy audits, and the sustainable future. So that is the basic part for the Vikasit Bharat 2047. So I will share my screen. So if you have any doubts on that one, you can ask at any time. There is no issue. And I will share my screen. Once again, the screen is visible and the voice is clear to all of you.
Yes, sir. It is visible.
Okay. So that today's topic will be the energy efficiency for sustainable future. So there are two terms. One is known as energy efficiency and is known as the sustainable future. So so actually aims to build, develop. So energy efficiency is the foundation. We can say it is the foundation for this developed energy efficient sustainable future. So also the energy efficiency is the fundamental term, or we can say the foundation for a sustainable future and sustainable economy of India. So I will be moving to the part that what is meant by the energy efficiency and what is a sustainable future and what our KAISM, that is a Save Energy Mission project is there. So what we are doing for the development of Indian economy as a national mission. So there is a project is there that is a Save Energy Mission. So that is known as the KAISM. So KAISM is a national level initiative that is under the Ministry of Power, Bureau of Energy Efficiency, for the energy efficiency and sustainable development. So it has to be a national level decarbonization mission that is called as the Kodak IIT Madras Save Energy Mission. primarily supports the micro, small and medium scale enterprises that you already know, that is the MSMEs across all over India by conducting the energy audits, then carbon emission and GHG emission studies to enhance the overall energy efficiency and reduce the carbon footprints. So India is very much needed for the energy efficiency improvement because there is an increase in the energy for every day, and our requirement will be increasing, but the generation is presently not that increased to very high level. So energy efficiency will be a very important part for the economic development of India. That's why we have a project that is a Save Energy Mission. That is basically it is done by the IIT Madras. Now it will be in the other 9 IITs, including that Madras. There are 10 IITs. This project is there. We are doing the national level energy audit and carbon assessment for all over India for the development of the nation. So basically, I am basically working from the IIT Kanpur as a part of this project. Okay. So the first part, that is energy efficiency. So you already know that is Vikasit Bharat 2047. Actually, that is aims to build a developed, energy efficient, low carbon and sustainable India by improving the energy efficiency. So that is the basic part. Other, you are already there, the modern trends in the renewable energy and other latest technologies are also there. But the basic things, but that is by improving the energy efficiency and reducing the carbon emissions. So we are also promoting the clean technologies. You already know the clean technologies, that is solar power, wind technologies, and that will be the foundation for achieving the net zero targets by 2070. So that's why we are telling that energy efficiency or improve the energy part of every equipment, as well as the building your home, as well as the industries, as well as the equipments. That makes the transformation for the economic growth and also for the development of the nation, which will be improves your complete sustainable development of the country. So that is our aim. So that is the major part of the project also. Then actually the energy efficiency is a systematic approach that we are using, that the systematic approach using less energy to deliver the same or improved level of performance. That is known as the energy efficiency. So we can say very simply, from general point of view, if you are replacing an old incandescent lamp with a LED light, so you are reducing the energy conservation, or you are reducing the energy. So there you will be saving the energy also. So that is the same. Without affecting the performance, we are improving the energy efficiency of the systems as well as the industries. So it will be automatically thereby reducing the energy cost, conserving the natural resources, minimizing environmental impact, at the same time maintaining the quality as well as in the productivity. There is no change in the quality of the product. There is no change in the productivity. Without compromising these terms, we are reducing the energy cost, thereby improving the productivity. So our aim is to improve the energy of the industrial sector. So we are mainly focusing on the industrial sector. So thereby reducing their energy cost or reducing their energy bill, thereby improving their profit and increasing the cost, thereby getting they are to be more attractive and productive in the economic development. So for improving the energy efficiency, we are doing the energy audit. So energy audit for the industries is the basic thing, that is a systematic examination. So how energy is used in a facility or process, that we are doing in the energy audit for the industries. So it involves actual the measurement. First part will be the measurement and analyzing the energy consumption. So how equipments will be utilizing the energy, what is their efficiency of the equipments, that will be measuring and analyzing with our modern instruments. Then second part, identify the areas where energy will be wasted and how much energy will be wasted in the motors, how much energy will be wasted in your AC systems, and how effectively we can utilize that wasted energy. So that will be the second part, identify the areas where energy is being wasted and how much energy will be used in the and the third part is we are giving the recommendations of energy bill and how to improve the energy efficiency of the equipment. So that will be the given the recommendations. First one is the measurement and analysis and identify the areas and recommending the energy conservation measures and technical feasibility. So all the recommendations will not be the technical feasible. So evaluating the technical feasibility and economic viability of the recommendations and implementation. So preparing an implementation plan to reduce the energy consumption while maintaining or improving the productivity. So that is the major part we are doing as a part of our energy mission. So the voice is clear, and if you have anyone have any doubts, you can ask at any time. Once again, you can answer that. The voice is clear, and the screen is
Yes,
clearly
sir,
visible.
clear, sir. Clear, sir.
Yes, sir.
Okay, okay. So how the energy audits? The first part will be energy efficiency. Energy efficiency has to be increased or improved by the energy audits. So how the energy audits contribute to the Vikasit Bharat vision or India's development? So the energy audits actually identify the energy saving opportunities. So either you can see in a home or industry or any equipment in your home or industry. So how you can save the energy? Your small things also. So you are just putting a sensor where the person will be there, only the needed energy will be utilizing. So otherwise it will be automatically switch off your lights and fans. So that is also very simple things. So that identifying the energy saving opportunities, how much energy you can save by the very simple things also. And that you reduce the operating cost. Automatically there are three costs. If you consider in the industry, there are three costs. So one is known as the energy cost, one is known as the raw material or the material cost, and third one is known as the our employees cost or labor cost. So these three will be the major contribution to any industry for their productivity and the developments. So if you are saving, we are mainly focusing the energy sector. If you are saving their first part, energy part, so that will be the major contribution. Approximately 30 to 40% of their total cost will be contributed by the energy, not only the electrical as well as the thermal energy. So that automatically reduce their operating cost, increase their profit. It will be give the more development to the company. So that is the reducing the operating cost. So automatically, if you are reducing your energy part, there is a reduction of the carbon emissions. CO2 will be related to this energy part because most of the power stations will be the India, the 50% of the power stations will be thermal based power stations. So thermal based power stations, there is a large quantity of CO2 and greenhouse gas emissions will be there. If you are reducing your energy usage, automatically there is a reduction in the carbon emissions. So the lowering the greenhouse gas emissions, improving the equipment reliability and productivity, supporting the compliance with the national energy conservation initiatives, and industries, move the industries towards the sustainability as well as the ESG objectives. So that's by doing the energy audits, we are directly moved to the Vikasit Bharat mission for the development as well as for the increasing the energy efficiency and for the sustainable development. So that is why the energy audits also a very important part in the energy efficiency and for the sustainable development. So that is the first part of energy efficiency. So what is meant by the sustainable future? So you already know that is what is the terms. The terms will be very familiar. That is sustainable future. The sustainable future is the one where you have some resources. So that has to be efficiently and effectively utilized. That is known as the sustainable future without any environmental degradation. So ensuring the environmental protection, economic development, and not affecting the future generations. So that is known as the sustainable future. So that is the basic definition. Sustainable future is a future which needs the present generation. So whatever our needs, present needs has to be met. At the same time, there is without compromising the future generation to meet their own needs or without affecting the future generations. The next generation, it cannot affect the next generation. Without affecting the next generation, we are fulfilling our present generation needs. That is known as the sustainable future. So sustainable future is a very important point. So that sustainable future can be done, or the foundation of the sustainable future for the energy developments. So that part for the energy development, the energy efficiency is the foundation. So that's why we are telling that energy efficiency is the foundation or the basic building block of a sustainable future. So sustainable future is the one where resources are used efficiently and responsibly, ensuring an environmental protection, then economic development, and social well-being for the present as well as for the future generations. So that will be the very important part. So all of them, the students also very need to understand that what is meant by the sustainable future. So without affecting the environment, you are meeting their own needs and you are providing the economic development of the nation is, we can say, that is known as the sustainable future. So how the energy efficiency affects the sustainable future? So by reducing the cost, so automatically by doing the energy audits, we are improving the energy efficiency, or we are giving some methods to improve the energy efficiency. And equipments, the new equipments has to be with the newer technologies and latest trends, thereby reducing the cost, conserving the resources. So for the power generation, we need fuel. That fuel, either it is in the coal or diesel, that will be only limited access. So by conserving these resources, you are keeping this resource for the future. So automatically there is a reduction in the CO2 emissions, enabling the economic growth and protecting the environmental part. So these are the major part of the foundation. So that's why we are telling that energy efficiency is the foundation of a sustainable future. And why the energy audit? I think it is for most of them are students. Saranya, this most of the are from the students background or from the faculties?
No, sir, most of them are faculties.
Faculties, okay. So why that energy audit? So it is a, you can tell that for the future students also, that is energy engineers or energy analysis engineers, and opportunity for the India's mechanical, electrical, then related chemical branches. There is good opportunity for the engineers to become the energy auditors, and energy managers will be for the economic development. That will be contributing the economic development of our nations also. So that will be very important. Why the energy audit will be very important? So you are all think in the this faculty development program, we already discussed so many latest technologies, latest trends in the renewable sectors. But the basic things will be the analysis of the present efficiency, present energy part, and take the steps for reducing the wastage of energy and improving the energy efficiency. That is the basic part. That is the first part you have to do for improving the energy efficiency. Other things will be also needed to do with the latest technologies, trends, and others. But is the basic part will be the wastage has to be reduced. If the energy wastage has to be reduced, this energy can be utilized for more consumers or more generations. So that will be the basic part. So that basic part we are doing through the energy audit. That's why this mission, that is Save Energy mission, will be focusing in the initial part as the energy audit by reducing the wastage and improving the energy efficiency of the equipments and the industries, thereby serving this energy to the more generations or more consumers. So that will be very important. Why that energy audit? So the energy audit, instead of other things, because other new technologies and others, it will be a low risk, high return opportunity for the industrial sector as well as the commercial building sector and other large industries also. So what we are identifying is we are identifying the present situation of energy usage and what are the equipment, what are the wastage of energy, how much energy will be wasted or not effectively used, either in the terms of heat energies or the leakages or the compressed air leakages. So many part will be there. Identification. So that identification, we are so much investment will be required to improve the. So that's why it is known as a low risk, high return opportunity as the energy audit. So identifies the hidden inefficiencies. So where the energy has to be wasted and how much energy will be actually needed for an equipment to operate. And for the equipment to operate, how much current, basically how much current they need to take and how much power they need to take and how much energy will be converted into effectively at the output and how much energy will be wasted as in the other forms as heat or thermal energies. So that identifies the hidden inefficiencies. That's why we are telling not only the electrical energy, it is in the terms of thermal energy, then compressed air leakages, steam leakages. So that everything will be identifies the hidden inefficiencies. And the second part will be the improves the operational performance. How you can improve the performance of the equipments? Very simple, that the motor, if you are using a motor without any variable frequency drive, and the motor has to be operated for the variable load condition. So it has to be operated at 30% load. It has to be operated at 40% load. It has to be operated at 80%. Different loads, the efficiency will vary. So if you are installing a simple VFD, variable frequency drive for the motor, automatically it improves the operational performance. Capacity of the VFD will be required of the VFD that we are identifying, that is improves, automatically reduce the carbon emissions, increase the revenue and profit, especially that we are doing for the MSMEs. MSMEs, there is no idea about their energy usage, energy wastage, and equipment effective utilization. So that will be automatically improve the industry's revenue as well as to the profit. And also one more things, this is not from the simulation or not from the approximation. Actually, we are doing the going to the industry, We are using with our modern audit instruments. We are measuring with the real-time data in the working time. So if it is to be operated for a 24 hours, we are operating our power analyzer for the 24 hours, identifying the load pattern, identifying the peak load, identifying the maximum demand. So that is not like a simulation, or it is the actual performance by the modern. We have the very modern, IIT have all the modern latest equipments for the measuring all the that one. So that's why it is to be very important as a part of energy development. And the next part, why we are more focusing on the MSMEs. So MSMEs means you already know micro, small, medium enterprises. So that will be classified according to their investment and their profit or the return on that one. So that will be, they will be different classifications. So industries will be differently classified into different terms. So it will be small, will be micro, first part will be micro, then small, medium, and large industries also it will be there. That is MNCs also will be there. So actually in India, there are 7+ crore MSMEs which will be contribute nearly 1/3, approximately 33% of India's GDP, driving India's manufacturing and economic growth. So that will be the basic part for driving the nation's economic development. That MSMEs will be the one of the part that driving India's GDP. So that's why we are mainly this mission or Save Energy mission mainly focus on the MSME sector. So for them, that energy is also one of the major expenses. So that will be one more important part. That energy means not only that electrical energy, industrial sector, either it will be in the case of air leakages. So all the things will be considered as a energy part. So that is the basic misunderstanding. Energy is not only in terms of electrical, it is all the terms of thermal energy, electrical energy, all the energy can be considered as the one part. And second part, there is no dedicated energy managers or energy auditors for this part, and the lack of technical awareness and detailed data. Very large industries have also access to the modern data. So these small industries don't have the detailed data for analysis. And our aim is to MSMEs make it as globally attractive, and that will drive India's economy in the future. So why that KAISM? So KAISM is a national level initiative from the 10 IITs. So why KAISM? So for the specified industries, which are some limitations will be there. Accordingly, we are doing the free audit. Some fee waiver will be there for the energy audits. So according to their investment, number of employees, and their profit also. So that will be considering as a different factors. And some of the industries we are doing for the free audit as a part of this National Save Energy Mission project. So that is team with the accredited and certified auditors, modern energy audit, technical guidance, and we are giving the monitoring and continuous support also. So that is the technical guidance. And this will be the very important part. What are the process in the energy audit? So it will be for the commercial establishments, industrial establishments, and very large industries also. This will be the part for the energy assessment protocol or the procedure for the energy audit. The first part will be known as the pre-assessment phase. So there are 3 phases. The first part will be the pre-assessment phase. So the pre-assessment phase, there are 3 procedures. One is the data collection. So firstly, we will collect the equipment details, the nameplate details of the equipments, and the electricity bill for minimum for a 1-year period, then the diesel fuel bills for the 1 year, the present performance of the equipments. So that will be the data collected for the all the equipments, all the energy utilizations, and that will be known as the data collection. Firstly, that is the initial part, and second part will be the walkthrough audit. So walkthrough audit, we are going to the industry, understand the process and how the equipments are to be utilized. So that will be the walkthrough audit, just an overview of the process of the industry and understanding the number of equipments that will be utilized. So that part will be known as the second part, that is known as walkthrough audit. And third part, from this initial data, we are moving to the detailed audit. That planning will be the third part, that is the measurement planning, how we can do the energy audit and which equipments or which part of the industry has to be more focused. So where that energy savings has to be there, or and how the wasted energy can be utilized for some other purposes. So that is known as the first part is known as the initial assessment, that is known as the pre-assessment phase. Then second part is known as the assessment phase. So there we are doing for the detailed audit. So the detailed audit with our energy audit, modern energy audit instruments, it will be taking 4 to 5 days according to the type of the industry, number of equipments, or we can say the number of or total the energy bill related to the LRG bill. It is in the 2 crores or 3 crores. Accordingly, it will take 4 to 5 days for the detailed audit. Then performance. After the detailed audit, the measurement has to be taken. The performance of the equipments, either it is for a compressor or for a chiller, that the performance analysis has to be done. And from the performance analysis, we have to done the closure meeting. We will give the whatever findings to the management. So there are different options will be there. Without investment options will be there. With investment options will be there. With the large more investment will be there. And similarly, we are calculating the break-even point or simple payback period, and how much time for investing for some amount of money, how much time it has to be returned back in the terms of energy saving and in the terms of monetary savings, cost savings. So that will be clearly implemented in the closure meeting. So that is the second part. First part is the pre-assessment and second part is the assessment phase. So detailed audit, performance analysis and the closure meeting. And the next part will be the data analysis. That will be that's why we are telling about that there is a lot of opportunity for the energy engineers and energy auditors. The data analysis, analyzing the data, and we have to prepare the detailed report and implementation part, the technical support and help for implementing the new technologies or implementing the activities. Very simply, if you are needed to install a solar system, so that will be effectively how effectively it has to be implemented. That things, it is just for a simple understanding like that. Or it is a waste heat recovery system will be there, how to implement the waste recovery. That implementation support also we are giving. So measurement phase, initial phase, measurement phase, and implementation phase. So automatically the industries has to implement the methods, and they will be feeling the reducing their, practically they will be reducing their energy cost. So they will be saving some part of their profit and increase the profit, and the revenue has to be increased. Automatically they will be more competitive in their field of operations. So that will be the 3 phases: pre-assessment, assessment, and post-assessment. Okay. This is just for your information only. That will be, is a detailed one. So how much assessments we conducted for the industries? 352. Then how much recommendations we provided, and how much the sectors will be covered. As a part, how much energy that is in the metric TOE, tons of oil equivalent. Actually, it is and energy auditing unit term. So that is the metric TOE, annual energy savings. Then accordingly, how much cost saving has to be there in the industry, and the GHG emissions, then implemented part and implemented cost savings also. So that would be the part. So this is also what is the previous condition after the KAISM, but we are going to do the real-time implementation, not only the recommendations, we are giving the real-time implementation, and we are saving each sector 20% of energy saving across the all sectors. So that, okay. So any discussion or any doubts, because this will be a new part to most of the faculty members. So that's why any doubts or any discussions or any questions from your side, you can ask it now. Then we'll go for the other part, because this will be more related to the industrial sector. As a part, you are from the academic background and others, it will be more related to the industrial sector, and there are a lot of opportunities your students and other members to enter into these energy sectors. So basically from the core field. So any questions or any discussions from your side? Charanya, any questions or?
Sir, I think there are no such questions from participant side.
Okay, so because the students will be very difficult to that one, it will be in the different field, and faculty members also, if it is the, you can ask any questions, because it is an industrial sector. We are mainly focusing from the industrial sector energy efficiency part. So this will be new sector for them. So what I want to convey is a very good field of opportunities for doing that simulation with something that is in the real-time data by using that energy audit, latest energy audit equipments. This power quality analyzer, it will be costing about 13 to 40 lakhs of amount. So this IITs has the opportunity to use this latest modern equipments. With these modern equipments, and we are going for the industries, either it is a small industry or the large industries, we are analyzing the real-time data, real-time motor data. So how much current actually they are taking for 24 hours of time. So how much power factor they will be there in that 24 hours. So what is the variation in the power factor? What is the variation there, harmonic distortion, and what is the quality of the power supply? So that will be analyzed using our energy audit equipments. So these are the normal. So this needed to be, I think it will be very much familiar for the electrical. These instruments needed to be familiar for the electrical or mechanical students. That will be useful for them for the future job opportunities also. So that is, there are different audit equipments, just for your information. One is power quality analyzer. It is measuring the real-time power data. So either it is in kW, or it is in kVA, or it is the reactive power in kVAR, the power factor in real time. Then the harmonics. So third harmonics, up to 50 harmonics, it has to be measured in the real-time data. And also the variation, it has to be plotted in a graphical format. So from the day 1 to the next day 24. Normally it has to be operated for a 24. We are connecting at the 11 kV line, or we are connecting at the 440 volt line, and it will be connected for a 24 hours of the day, and we will be analyzing the data for 24 hours for their load variations, then demand variations, power factor variations, the harmonic spectrum, then harmonic analysis. So that it has to be done with the power quality analyzer. Then the next part will be the acoustic imager. So the acoustic imager, actually it is for measuring the air leakage, then steam leakages. So that has to be measured by the each point. It has to be measured how much leakage will be there. If you are using for a 1 hour of data, how much the quantity of air leakage will be there, compressed air how much is the steam leakage. If you are using for a boiler, that has to be indicated by the acoustic images. There are safety audit. Mainly for the safety audit, we are using the thermal images, then differential pressure indicators, temperature and humidity data logger. These data also you can to be analyzed in the real time with your laptop as well as to your mobile phone. So at the same time, we can get the data instantaneously in a timely interval. Either it is 1 minute or it is in the 5-minute data. So you will get it for that one. Temperature and humidity data, that's this Clambon meter and others. This is water flow. So that is the flow, how much rate of flow has to be indicated by the ultrasonic water flow meters. Then flue gas analyzer. Flue gas analyzer is for analyzing the components of in the exhaust gas. How much CO2 emissions will be there, how much the oxygen content will be there, how much NOx content will be there, how much sulfur content will be there. That has to be analyzed by the flue gas analyzer. And anemometer for the airflow, lux meter for the quantity of light or the light intensity has to be measured. So actually in the working plane, it has to be the working plane, how much light has to be needed and how much the extra light you are using. Or accordingly, you can select very simply, you can select the number of lights, the wattage of each light. So that will be there. Then tachometer, you already know that will be for the speed measurement. Then psychrometer for the dry bulb and the wet bulb temperature measurements. These are our real-time measurements. So we are going for the industry. We are connecting the 11 kV and as well as the 440 volt lines. So with our meters, that is not to be, it's in the off condition. We are connected with the safety shoes, safety equipments with the real time. So that is in the working condition. Then only we'll get the working data. So if the 11 kV light, we have to be connected, then only we'll get the real-time data in the 11 kV line, or it is in the 440 volt line. So that will be without disturbing the operations of the industry. So the water flow meter, these are some of the real-time data measurements we have to be taken. So these are also, I think, it is a modern type. So how much you can understand, I also don't know. So that is from this part. So this is for the compressed air leak studies, then steam leakages, then partial discharges, the mechanical vibrations in the industry. So that also monitored by this audit equipments. So anyone can, before it has to be utilized, or any doubts from this side, you can ask it that one. So because I don't know how much you can able to understand, it is some modern equipments and modern facilities that has to be utilized for the energy efficiency and the energy auditing part. So these are the some of the images. So automatically that the position of the leakage, either it is a compressed air or it is a steam leakage, that has to be shown, as well as the leakage quantity has to be indicated in the dB. There are different units will be there that has to be indicated in the dB scale. So accordingly, if we can calculate steam loss or energy loss, and how we can, with some small arrangements or something, that sometimes it is a loose connection or something. So that also we can identify and we can save this wastage of energy. So there are different methods are there. So the mechanical vibrations of the industry. So that will be also this part. This is also one safety part from the thermal imaging part, that electrical panel safety. So how much temperature, if any extra temperature, there is a normal temperature will be there for the bus bars and others. Similarly, there is an increase in temperature, it has to be automatically monitored. So that what is the reason for that temperature, either it is a contactor problem or it is a relay problem, so that we can identify. So it is a part of safety audit also. So that electrical panel, the steam trap health and steam line losses, chilled, it is in the case of chiller part, so chilled water system losses. Then solar PV in the solar system, that is a hotspot identification. So how much is cells? So it is a panel. Means there is a lot of cells has to be connected in the one panel. So each cell, any damaged or defective cells will be there. So that hotspot identification also done with our audit instruments. That part is known as the thermal imaging part. Okay. So these are the somewhat details part. I think that is. So just for 2 minutes,
Sir,
yes,
we are having a question from participant side.
yes, you can ask.
How much
Question
will
has
be the
been put in the
cost for
chat box.
acoustic imager and thermal imager?
Yeah, that will be in, I will show to you that one. So there are different parts will be there. We are using that our acoustic imager will be the II 500. So this acoustic imager is approximately costed 30 lakhs. Thermal imager is not in that much. Thermal imager is in the range of 3 to 4 lakhs. So that will be vary from your equipment. That is different models will be there. Different models and different companies will be there. This is the Fluke acoustic imager, and this thermal imager also the company name is Fluke. So that will be somewhat II 900, and thermal imager. I want to check that model. So ultrasonic thermal imager is testo 872. So that will be depend upon the different models. But this acoustic imager, it will be approximately 30 lakhs, and thermal imager, it is in the range of 3 to 4 lakhs. So any other question?
No, sir, no more questions.
Okay. So can we continue? It is also somewhat details.
Yes, sir. We can continue.
Okay. So so faculties already know that it's a power quality study. So that the power quality study has to be done with the power quality analyzer. So there are so many things you can use it for the your labs also. So it is for the load analysis, then power factor variations, then total harmonic distortion and harmonic spectrum analysis. So that you can use with the power quality study. Normally it is, there are some IEEE limits will be there. So with the IEEE limits, there is each part, that is the incomer of the transformer. So this much will be the maximum limit for the harmonics. So that limit will be there. That will be checking in the industry. We are checking with the industry. It is in below the value or above the value. Accordingly, sometimes there is some recommendations. We are giving the recommendations or some adjustments. Accordingly, we can vary. Sometimes it will be from the quality of the supply. So from the grid supply, in some areas, the grid supply that much not be good quality. So that will be with the power quality study. So that the faculties can be used in the lab. It is a very good instrument to analyze the things in that one. So it is needed for the power analysis. So that will be getting the real-time data. We can convert into your graphical, whichever the format you needed. It is in the 24 hours graphical format, or in this like bar charts and other things. You can convert into the your suitable. That analysis can be easily. We can do the analysis. That's why there is a lot of opportunities will be there. So you can do the energy analysis. So from that you can, the quality of your supply also has to be needed to analysis. That we are doing that is part load analysis from, normally it is for the 24 hours. So one time 8 for 2026 to 9 for 2026. Normally with the same time we'll be starting the power analyzer, and we will be put to 24 hours. After 24 hours, it will automatically switch off, and all the data has to be plotted, or all the data has to be stored in the power quality analyzer. So that the load analysis, calculation of the load factor, then quality of the supply. So that everything we can do with the load analysis. So that will be in the different form. Either it is in the terms of kW, or it is in the terms of kVA, or it is in the terms of kWh energy, active energy, or sometimes it will be in the apparent energy, kVAH. So that things we can do for the load analysis. So these are some of the harmonic spectrum THD analysis. So the variations, the percentage variation has to be analyzed in the total harmonic distortions. And we are going for different utility equipments. So the each utility equipments have different models will be there, different capacity will be there. So the compressor, you already know, it is for the giving the compressed air for the process requirements or the pneumatic applications, or moving some parts to other parts in the case of transportation. So all the things in the industry, there is a lot of need of the compressor. Actually, the compressor will be the least energy efficient equipment. There are so many chances of leakage and so many wastages in the energy. So much energy has to be wasted in the compressor. It has so sometimes the compressor has to be operated at the pressure settings. What is the required pressure for the equipments? So if it is in the 6 bar, if they are setting the pressure at 8 bars, it will be a large difference in this, the requirement and the setting pressure. So that actual requirement has to be matched with the pressure setting requirements. Automatically, there is a saving in the energy part. So that's why it is a loading time and unloading time will be there. That will be very important as a part of compressor as the energy consumption. So that has to be analyzed correctly. If it is no VFTs are there, we are putting the variable frequency drive. So that will be give you some energy savings, some cost savings, and effective utilization of the equipment. So automatically the life of the equipment will also increase. So that part is known as the analysis part, that compressor analysis. And actually these are not to be in the we can do with the assumptions or not like that, assumptions or simulations. It is from the real data. We are going to the industry, we are taking the measurements. Then sometimes all the equipment has to be operated, or in some part of the time the valve has to be closed and the air has to be turned on for taking the time to full load. So that time also we can measuring, and accordingly we are analyzing the data. I'm not going in very detail. So that will be, these are the leakage losses. So you can see from the compressor also there is a monetary savings of 7 lakhs per year. For a small industry also, it is in the 7 lakhs per year from the compressor only. For an equipment like a compressor, that is savings will be, that much of savings will be there. It will be, I think, 4 compressors are operating for the industry. So that 4 compressors will be contributing so much of energy, and that savings also, it will come to a 7 lakhs of savings with this actual settings and changing the pressure requirements. So these are the pressure reduction techniques and others. Then that will be the loading and unloading losses. So how much time it has to be loaded and how much time it has to be unloaded. So that is observation of this data for a particular period of time. So that will be give you the savings part also. So these are the actual our practical explanations for that one. If anyone needed to be in more detail, you can contact. We will give you that details. Otherwise, I don't know all of them can be able to understand or not. If any industrial persons are there, they can easily understand. But So that is a variable frequency drive. Normally the variable frequency drive has to be operated according to your load requirement. Load requirement, it has to be vary the frequency, vary the speed accordingly. It will give the correct compressed air or output to the load. So the frequency variation will be very important. Vary from the right frequency variation, either from the 45 to 55 or 40 from the 50, according to your variable speed or variable requirements. So this is a, you can see the figure, it is a oven. It is a food manufacturing industry. It is the, you already know that the Parle-G will be one of the big manufacturers of the biscuits. So they are using a lot of ovens for baking the biscuits. It is from one part baking, cooking, everything will be in the this oven. So they are using the PNG gas, pipeline natural gas oven, for the baking at the particular temperature, and after that it will be cooling and it will be mixing with some cream or some sugar type items, so for creating the taste and others. So that will be there. So if you save that PNG will be also very costly, and they have to be 8 crores to 9 crores of PNG gas to be used for each month. So that if you can save a little amount also, that will impact in the profit in very much high level. So that PNG oven, there is a combination of air has to be mixed properly. So that is for proper combustion. Proper combustion, the correct amount of air has to be mixed with PNG, and then only the proper combustion and proper rate of fuel has to be taken by the that one. If the your air level or excess air has to be utilized, the combustion is not to be proper, and the PNG has to be more to be utilized. So it will be wastage of PNG as well as the wastage of energy also. So it will be a cost reduction part. So that we are using with the one equipment will be there, that is known as a flue gas analyzer. So the flue gas analyzer, it will be correctly measuring your air content, oxygen content, so nitrogen, all the other components, CO2, like that, whatever the components will be needed in the part separately, NOx, OX, O2, etc. So that has to be calculated separately. And from that, we can calculate the combustion will be proper, or the air has to be properly mixes with this fuel and the proper combustion, and the biscuits has to be in the proper temperature, baked in the proper temperature, and it has to be in a proper period of time. So it has, the movement has to be in a proper period of time. That things has to be analyzed very effectively. So that are the practical things we are doing, that one, that is the monetary savings. This for just understanding this figure, it will be known as the cooling tower, CT. So basically one of the equipment used for the chiller part, so cooling tower. It is also normally used in the thermal power stations. That is a natural cooling tower. It is not a natural, it is a forced draft cooling tower. So cooling the water, and it has to be utilized for the chiller part. So hot water temperature will be there, then cold water temperature will be there according to the temperature difference. So this cooling tower produce the cooling to the water, and it will be again returned to the process. So that temperature difference is to be properly maintained. So if you are maintaining the proper temperature difference, then the effectively the cooling has to be happened and the energy has to be utilized. So there are so many methods for analyzing that one. Temperature, we have the temperature analyzer, humidity analyzers, then fan speed measurement. So that has to be done with the cooling towers. So these are the observations and the different types of chillers, air cooled chiller, then water cooled chiller. I'm not going very detailed. Boiler efficiency part. Then similarly for the furnace, also it will be the temperature requirement, molting metal requirement, the insulation, refractory materials also affect the energy efficiency part. So that will be analyzing as a part of our audit. So any other 2 minutes I can give, any doubts or anything from that part, or anyone needed more in detail, I will explain to you. Otherwise, we'll go in that way only.
Sir, we are having a question in chat box.
Yeah.
Is it possible to completely reduce the energy losses like mechanical vibration, electrical surges, etc.?
Mechanical vibration, sometimes it will be required. Some part of the vibration will be required. We cannot eliminate completely, but the excess vibrations, so the limits will be there. The vibration analyzer will give you whatever the which will be. If the motor is operating, actually there is a small vibrations. It is always there. Either it is a good motor or not a good motor. Some vibrations will be required, and some vibrations will be there in that equipment. It cannot be reduced to zero. But if the more vibrations will be there, that will be affect the operation of the equipment. That will be affect the life of the equipment. That will be affect the efficiency of the equipment also. That we have to be analyzed and we have to be reduced as per the proper limit. Then the partial discharges also. Partial discharges, sometimes it will be the discharges has to be in the time limit. There is a small time within the seconds of time that the partial discharge happen, and then it will be there. But most of the partial discharges not to be required. Actually, that we can eliminate also. But some of them will be that according to the part also it will be required, that we are not able to avoid it at also. So that is like mechanical vibrations also. Some part of vibrations will be there, but that part will be limited. Any other questions in chat box? Or
No, sir, no more questions.
so these are also in very detailed part. So melting furnace, thermal savings. Then there is a one term that everyone want to understand, that is specific energy consumption. That will be the very important term for comparison of the industrial sector. Energy consumption by production. So automatically if the production will increase, energy consumption will increase. So we are comparing with the SCC, specific energy consumption by production. For each sector, there are some standards will be there. So according to that standards, we can compare the different industrial units for the same sector. If it is a steel industry, there are different steel industries are there in the different parts of India. So we can compare their performance with the SCC, that is energy consumption by production. They are in the normal, it is in the limit, or their performance will be very poor, or the performance will be very good. So we cannot able to compare only in the case of energy consumption. Energy consumption will increase as well as the production will increase. And the production is normally, it is not a constant part. It will be according to the customer demand, or it is in the client demands. It will automatically vary from month to month. But for the comparison part, what we are doing is the specific energy consumption by production. So that will be give you an idea about the industrial performance of the same sector in the different units. So that will be one of the very important parts. So this part, any doubts, you can ask it that one. So it will be just steam systems. It is an powder plants are there. Then RO plant is two types of that. Sewage treatment plant is there and the water treatment plant is there. So that also we are observing that one, both the plants. So what is the performance, what is the energy efficiency part, any recommendation we can give, and the motor. There are different small motors are there. They will be either it has to be operated continuously or it has to be operated in the intermittent time. So that RO plant also we will be continuously monitoring that one. So is it properly working and the energy efficiency of the plants will be proper. So how much energy has to be utilized for these plants. So these are also one of the important parts. Basically, every industry, normally there are so many equipments will be there. So many chances of energy saving. If you monitor, the first part will be that one on the monitor. There are some more modern techniques are there, IoT, small plants, it will not be economically feasible. So that also we are using also some of the IoT based equipments for the real-time monitoring. So monitoring will be the first part, and after the continuous monitoring, then analyzation of the data will be the second part, and third part will be after analyzing the data, the recommendations will be given. As per the recommendations, we have to implement the activities, and from the implementation, you will get the savings part. So there it is not an instantaneous process; it is a continuous process. So energy audit is also not a one-day process; it is a continuous process. And after that, the monitoring and the verification will be there. We are monitoring the improvements. So automatically, if any mistake or something will be there, we will be correcting that mistake. So automatically, it will be giving the feedback. So that is a continuous process. It is a step-by-step continuous process. Through the continuous process, we are doing the auditing part. Okay. So these are our detailed report. It is an energy audit. There is a detailed report. So this will be the structure. We are following that one. Some observations. Then second part will be the recommendations. Then the KWH, the savings, how much saving you are, if you are giving these recommendations, how much energy savings, either in terms of KWH, if it is a PNG in terms of that SCM. So what is the unit of that one? So accordingly, so how much energy savings in KWH or it is in SCM or some in tons of refrigeration, chiller in the case of tons of refrigeration. So which unit? So how much it will be the saving, and we are calculating the cost. So in that one part also it will be very important in the southern states with Kerala in industries. Normally the billing will be, there are two charges. One is known as the demand charges and another one is known as the energy charges. So the demand charges, it will be in the terms of KVA. Energy charges in southern states or some of the states in south, it will be in terms of KWH. So but in the northern side, it will be in the terms of KVAH. So that is the total energy base. So active power, reactive power, and total power. So similarly, active energy, reactive energy, and total energy. So KVAH will be the total energy. It has to be calculated in terms of KVAH. So, and in also in some cases, if it is in KWH billing, that power factor penalty will be there. But in the KVH billing, automatically your power factor will be less. You are using more KVH, automatically your bill will increase. If the power factor will be nearly unity, the KWH and KVH will be same, you will be less electricity bill also. So that will be depend upon the states and that will be depend upon the distribution boards. So either in the KVH or KWH. But effectively, the power factor will be also very important part. The power factor has to be nearly maintained to the unity or near to unity. Then the bill also we can reduce. So the power factor variation will be also important. So that will be the part that I'll be just once again. So this will be your observations, recommendations, then energy savings, as per the energy saving, what is your energy charge, what is the cost saving, and what is the investment will be required, how much investment will be required, and what is the payback period. So the total savings or so total recommendation has to be divided into 3 parts. So first one is the without investment. There is no investment will be required. Only the technicians can, the leakage has to be, we identified the leakage. You can close the leakages or eliminate the leakages by putting some, closing the taps or the changing the steam traps. So accordingly, there is some with the without investment. So that easily that the industry has to be implemented. And some savings or some recommendation will be there with the less investment. It is a small BFT, it will be only 25,000 or 35,000. Or it is a power factor, capacitor has to be, for improving the power factor, he has to install the capacitor. The capacitor will be only, it will be 10,000 or 20,000. So that low investment option will be there. So the low investment option will be, that is the more attractive. So we will be giving that to the management. So management can decide which will be the there without investment, then low investment, and some will be give more savings, but they will be require some investment also. The replacement of one motor, old motor with the new motor. So the motor replacement will be required some investment. Accordingly, some time will be get it for the each year you will get saving, but that amount has to be recovered in a particular period of time. So that will be known as the simple payback period. So the payback period normally it has to be below the 2 years. So above 2 years, it will not be an attractive option. So that's why the audit recommendations, observation, recommendation, energy savings, then cost savings, then investment and payback period. That terms will be there clearly, that one. So that will give you the clear idea how much investment will be required, and there are some savings without investment will be there. So there are simple parts. So that will give you clear idea about the how you can save the energy from your present performance. So this will give the idea for the engineers to evaluate their performance also. So these are some of the audit recommendations. So that is the part will be the energy efficiency. So the energy efficiency will be very important because it will be the part of your sustainable future. So this power generation, every day it will be increasing. So the power generation or the fuel requirement will be needed for the future generations also. The next generation also it will be needed for these energy types. So that we need to be identified, and they need to be, the wastage has to be removed. Then only it will be the development of the nation will come, or and also it is for the sustainable future. Sustainable future that is not coming to the environmental part also. So these are some bill analysis and others. So this is our final that one. So we are going for the audits in the different sectors. So normally it is in the range of, if you have a electricity bill of 1 crores, so then 10 lakhs will be the 10 to 25 lakhs will be their savings in terms of annually from that fund. That much of potential will be there in the different sectors. That will be depend upon their present performance, the equipment type, and the type of sector, either it is a steel sector or type of industry. So that will be the part. So this is from my side. So any doubts or anything from, you can ask the questions also. Or any doubts, if at any time you can contact that one. So because this will be different topics for you. I will tell you, there is a very large opportunity for this field in the our India's mission for Vikasit Bharat, as well as for the net zero 2070, that we are moving to the net zero targets. So there will be a lot of opportunities in this sector also. So anything more need to discuss or any questions from your side that I can answer?
Any queries from the participant side?
Or any chat box, any questions will be there. Sharanya, you can just check it that also.
No, sir. There is no questions. Sir, I think we can wind up the session.
Okay, so I'll be stop sharing. No questions or no chat box any questions. I'll be stop sharing that one also. So no questions, Sharanya?
No questions, sir.
Okay.
Okay, sir. On behalf of the organizing committee, I would like to express our heartfelt gratitude to our esteemed speaker for delivering such an insightful and engaging session. Your valuable expertise through provoking ideas and willingness to share your knowledge have greatly enriched this FDP. Once again, thank you very much for your enlightening session and for making today's program a memorable one. Thank you, sir.
Thank you for all. Thank you, Sripati, for all giving an opportunity to present that one. So it will be mostly it will be in the. I also know that when it is from the industrial sector, how much it will be utilized, you can. That will I also have some doubts. But if you have any doubts or any clarification from this part of that one, you can mail or you can contact. So that's I can give you from that one. Okay. Anyway, thank you all.
Thank you, sir.
Okay.
Participants, feedback form has been posted in the chat box. Complete it, please. വാസന്തി മിസ് ജോയിൻ ചെയ്തില്ലേ? നമുക്ക് സെഷൻ സ്റ്റാർട്ട് ചെയ്താലോ?
Vasanthi, miss.
Hello. Hello. കേൾക്കാമോ?
കേൾക്കണ്ടോ സർ?
Yes, miss.
Once again, a very warm welcome to all the participants to the second session of day 5 of our 6-day faculty development program. It is a privilege and an honor for me to introduce our esteemed resource person for today's session, Dr. Vasanthi V. Dr. Vasanthi is the professor and head of the Department of Electrical and Electronics Engineering at NSS College of Engineering, Palakkad, with over 25 years of dedicated experience in teaching, research, and academic leadership. Dr. Vasanthi has made significant contributions to the field of power electronics, power systems, power quality, electric drives, and renewable energy system. She is a recognized PhD research supervisor under APJ Abdul Kalam Technological University and has guided several postgraduate research scholars. Her research contributions include numerous publications in reputed international journals and conferences. She also served as the coordinator of Rs 30 lakh KSCSTE SAD funded research project. Dr. Vasanthi is an active member of professional bodies including IEEE, ISTE, and Institution of Engineers. She has also been honored with the IEEE IAS Outstanding Joint Chapter Award for her outstanding contributions to IEEE activities. Today, she will be delivering a session on recent trends in power electronics for renewable energy system. We are confident that her expertise and experience will make this session highly enriching for all of us. On behalf of Department of Electrical and Electronics Engineering and Sribadi Institute of Management and Technology, I cordially invite Dr. Vasanthi V to take over the session. Welcome, ma'am. The virtual platform is all yours.
Okay, thank you. Hope the screen is visible.
Yes, ma'am.
Yes,
Visible,
ma'am.
ma'am.
So today, I think this is the fifth day. So previously, the session dealing with power electronics for renewable energy system has been covered, I think. Anyway, now we'll see the key advancements in the power electronics field for renewable energy system. So basically, what is the need for power electronics in renewable energy system? So actually, the power electronics is the backbone of the renewable energy system. With the help of power electronic devices and circuits, we can manage, convert, and regulate electric power from sources like solar, wind, into usable and other power renewable energy sources into usable grid compatible electricity. So which includes DC to AC power conversion, then maximum power point tracking, which gives maximum efficiency, then voltage and frequency control as to meet our own requirements, then energy storage management, which will be enabling the renewable energy system, which can be stored and then reused. Now, the key advancements with the development of power electronic technology, the key advancements include wide band gap semiconductors. With the development of this type of semiconductors, that is silicon carbide and gallium nitride, they are replacing the traditional silicon and they allow for higher switching frequencies, reducing the heat generation and drastically shrinking the physical size of converters, which also enhance the efficiency of the whole system. So GAN is primarily used in low to medium power systems, example microinverters, EV charging, etc., while silicon carbide dominates utility scales, solar and wind farms. Then comes the intelligent controls, AI and digital control. Advanced AI techniques and real-time digital controllers are increasingly used to optimize the power flow and predict hardware failures. Also, to manage the hybrid energy setups, like combining the solar, wind, and battery storage. Now, coming to the power electronic circuits, advanced technologies. In addition to the conventional voltage source inverters, we can use multi-level inverters, then modular multi-level converters and string inverters. So multi-level inverters like the neutral point, clamped and cascaded edge bridge are now standard for high capacity wind and solar systems. They produce smoother and more or less sinusoidal waveforms, drastically reducing the total harmonic distortion and also eliminating the need for bulky, expensive filters, which will be reducing the harmonics in the conventional systems. Then modular multi-level converters and microgrids, they are growing in popularity for high capacity applications like offshore wind farms and high voltage direct current DC, high voltage direct current transmissions. Also at the local level, decentralized DC networks and microgrid power electronics are becoming the standards. Then comes the string inverters, which distributed maximum power point tracking. Uses microinverters to optimize the individual solar panel yields and mitigating the power loss caused by the localized shading. So these areas, when we are going for the research and all, we can do a lot of research work in these areas. So many papers are being published in these areas also. Then grid integration and virtual synchronous generators, grid forming inverters, which high penetration of renewables weakens the traditional grid inertia. So new inverter technologies enhances the physical, emulates the physical inertia and also the frequency response of synchronous generators, which allows the solar and wind systems to actively stabilize the grid during the frequency drops. Then as grid shifts from the traditional power plants to inverter, heavy renewable energy sources, new grid forming converters, which provide essential system inertia and voltage control and frequency support, which stabilizes the grid autonomously. So without making any control manually, we can control the voltage and frequency as per our requirement or as per the requirement from the consumer side. Then strict grid codes. So modern power electronics are designed for fault right through and dynamic reactive power support to ensure regulatory compliance across modern electrical infrastructures. Now comes the hybrid energy storage system, as the name suggests. So this is a combination of different types of storages. But with the help of power electronics, we can manage a renewable energy generation and also the battery energy storage system within a single hardware platform, providing peak saving and load shifting and frequency regulation. Then a hybrid, this will be pairing two or more storage technologies such as high energy chemical batteries and high power supercapacitors to leverage their complementary strengths. Now comes, so we will be concentrating slightly on grid integration part also. Just an overview. So this is the figure for the grid integration. So here comes the fuel. There is fuel cell, wind energy, then conventional production, then biomass, photovoltaic. All the renewable energy sources are considered here. So the power coming into the grid from all these power sources, and there is a demand side here. So the power is going out, and this is the integration of renewable energy system with the utility grid. So decentralized energy management system is also there. With the help of this energy management, we can utilize the power generated by the renewable energy sources wisely. Now, this is the classification of the power generation from the renewable energy sources. Large scale power generation means it will be connected to the transmission system, and small scale distributed power generation means it will be connected to the distribution side only. And this is a figure example or the figure for the large scale integration. So here, here the wind and solar power. This is the power generated by this wind and solar. They are transmitted through the overhead transmission lines with the voltage 230 kV, and this is the receiving station. And then from there, power is going into the distribution stations. It is a sub-transmission lines with 69 kV. And from the distribution side, this is coming to the consumers. So three types of consumers are considered here: residential, industrial, and commercial. So this is distribution lines are of 12.5 kV. And so this comes under the category of large scale grid integration. Now this is a small scale grid integration. It is a grid inverted with the battery backup. So here the power from the solar panels, with the help of charge controllers, they are converted and stored in the battery pack here. And from there, this is going to the consumer side. And there is a utility grid also through the net meter from the passing through the inverter. It is going directly to the consumer side and also to the battery storage system. Then this is for the wind turbine systems. So here again, power from the wind is taken out, and through the controller and through the inverter, grid tie inverter, it is going to the grid as well as to the domestic consumers or the consumer part, either domestic or industrial. So these are the renewable energy sources. So DC source, it will be generating power at the variable low voltage, low DC voltage, and fuel cell and photovoltaic energy sources. Then AC source with rectifier coupled to DC link. This will be generating power at various AC voltage with a variable speed wind turbines. And there is a DC link capacitor which decouples the RES from the grid and also allows the independent control of converters on either side of the DC link. Because the need for power conditioning is required when the power generated is from the RES. So for that, we are using the various power electronic circuits in order to get the sinusoidal supply with our required frequency. So there is a need for DC link capacitor also in some cases. Let us see that. Then this is a conventional voltage source converters which can be used without DC link, that is matrix converters. Then with DC link, that is 2-level inverters, Z source inverters and multi-level inverters. Among the multi-level category, there is a diode clamp, flying capacitor, cascader, and then bidirectional switch interconnected. So this is the DFIG wind energy system with a variable speed concept. So here there is a wind DFIG, doubly fed induction generator system, and here there is a two-stage conversion, AC to DC with the DC link capacitor here, then DC to AC. Then it is fed to the grid through a transformer. So there is a gearbox here which will be used for getting the required speed. So these are the part, and variable speed range in this case will be 70% to 130% of the signal speed. And this is the maximum market share currently. So this is a singly fed induction machine with 2 fully controlled AC power converters. So this is control over active and reactive power of the machine. So when we use this single doubly fed induction machine with 2 fully controlled AC to DC power converters, we need to control both the circuits, inverter circuits from both sides. So we need a control over the active and reactive power of the machine also. So this will be reducing the harmonics injected into the grid by the power converter. And the supplier to this market is Spanish company Gamesa. Now, single doubly fed induction machine controlled with slip power dissipation in an internal resistor. So I'm not just giving you an the circuits and all, not going to the control because of the time restrictions. So here, just variable speed is achieved dissipating energy in rotor resistor. Then efficiency is reduced when the slip increases. And this is the company producing this circuit. So here, when we see the diagram, there is a gearbox, wind vane, then variable resistor here, and there is a control circuit which is fired through this circuit here, and here the variable resistor power is dissipated in the variable resistor, so the efficiency will be reduced, and then it is feeding to the grid. Here there are 2 fully controlled AC to DC power converters here, and where there is this is again a 2-stage conversion, AC to DC and then DC to AC. Here the circuit remains the same, and then through the transformer it is fed to the grid. So again, control over active and reactive power of the machine is to be done. Then reduction in harmonic content injected into the power grid. So this is another scheme, single doubly fed induction machine controlled with slip power dissipation in an internal resistor. So efficiency is reduced with the slip when slip increases. Then double three-phase in the VSIs. So machine side three-phase converter works as a driver controlling the torque generator, and grid side the converter will be acting as a transfer. It will be used to transfer the wind energy into the grid. So this will be controlling the amount of active and reactive power delivered to the grid. And here the total harmonic distortion coefficient is low. So compared to the previous circuits, this will be having more reduction in the total harmonic distortion. And anyway, the control complexity will be there because there are two inverters which has to be controlled. Then majority of these wind turbines are equipped with a multi-pole synchronous generator. In this case, there is no gearbox as DFIG. So lower losses and cost and high reliability also. And Enercon supplies this converter. So this is having more advantage than the previous ones. Now, a step-up converter in the rectifier circuit and full power inverter topology used in the wind turbine applications. So this is having a diode rectifier at the front end, and then with the help of a filter, DC power is the ripple is controlled here with the help of this filter. LC filter is there. Then the inverter is at this side. Then it is fed to the load. So low cost as compared to an induction generator connected to a voltage source inverter used as a rectifier. Then by controlling the inductance current, machine torque can be controlled. Then Spanish company Made has marketed the design. So this is multi-level back-to-back converter for a direct connection of wind turbine to the utility grid. So multi-level inverters convert the variable DC power from renewable source, then which gives the output will be a stable AC power and which is compatible for the grid integration. So here the output is synthesized from the multiple DC sources or capacitors. Then it will be producing a stepped waveform, output waveform. So which will be more or less similar to the sinusoidal waveform. So as part of this, I mean, as at the output side, we will the harmonic distortion will be very minimized. Then it will be lowering the switching stress also because this is stepped waveform, and so the switching stress across the devices will be reduced, and also it will be increasing the overall conversion efficiency. And here the key advantages will be enhanced power quality. That is because it will be reduced, total harmonic distortion will be reduced, limited on grid infrastructure and connected devices. Then high voltage tolerance distributes voltage stress across multiple lower rated semiconductor devices. Because in multi-level inverters, we'll be using so many switches with lower supplies. So limited stress across the devices. Then smaller filters, stepped waveforms requires a smaller output filter, saving the space and cost. Then modular integration, easily interface with the multiple distributed energy source. So we can use multiple sources and using this circuit. Then which includes the individual photovoltaic strings or the battery energy storage systems. Then cascaded edge bridge, ideal for grid-tied solar application. So these are the different categories of multi-level inverters. So cascaded means it can be very much ideal for the grid-tied solar application. Then it uses isolated DC sources, avoiding bulky clamped diodes. Then comes the neutral point, high or the diode clamp, highly effective for high voltage and high power industrial applications. Then balancing, even though, but there is disadvantage for this neutral plant, that is voltage balancing is complex. Then comes the next version, flying capacitor, that is which provides the inherent voltage self-balancing, but requires large number of capacitors. Then the researchers are going on in this field also, switch reducing topologies. So customized topologies focus on reducing the number of switches and overall control complexity, which while maintaining the high voltage levels. So many researchers are going on in this field also. Then comes the HVDC transmission side. So there are two types, classical LCC based system with STATCOM and VSC based system. So this is the classical system, and the second B part is the VSC. So here there is a smoothing reactor here, PCC, then transformed and passed through the smoothing reactor with the STATCOM here. Then here again, two-stage conversion with a DC link filter here. And at the input side also there is a reactor. So these are the some of the companies which are providing the power converters for wind energy system. So here Cifros, they are providing the 4-quadrant IGCT converter, and GE Energy 4-quadrant IGBT converter, Siemens fully automated converter, then Vestas, it is a frequency converter, RE Power 4-quadrant IGBT converter, Multibrid 4-quadrant GTO converter, and the last one. So this is a variable speed wind turbine with a hydrogen storage system and a fuel cell system that reconverts hydrogen to the electrical grid. So this is the complete system. So from the wind, there is a power conditioning system here. Then this transformed. Then there is an AC to DC converter. Then it is stored in a fuel cell. Again, here there is a DC-DC converter. From the DC link, again, there is an electrolyzer here, then compressed and stored to, inputted to this fuel cell. So this is a system which reconverts the hydrogen. Then the PV cells connection here, grid connection application and power supply. So here there is a utility grid with an inverter. Then this is a solar PV here. So this is for grid connection application and this is for power supply application. So here it is connected to utility grid and here it is connected to the load. Then inverter families, central inverters. So these are some of the advanced technologies for inverters, central inverters, module oriented or module integrated inverters, then the string inverters. So central inverters are connected in parallel and or series on the DC side. And here one inverter is used for the entire PV plant. So the control complexity will be slightly reduced, but the reliability, since one inverter is used for the entire PV plant, so anything happens to that inverter means reliability is affected. So nominal power of this topology is up to several megawatts. Then comes the module oriented or the module integrated inverters. Several modules usually connected in series on the DC side and parallel on the AC side. So 1 converter per PV module, and this is implemented for PV plants of about 50 to 100 watts. Then comes the string inverters. Permits the integration of PV strings of different technologies. So this is an example for a string or a circuit for the single phase and 3-phase inverter, string inverter. So single phase multi-string inverter and 3-phase multi-string inverter. See the connection here. So each panel, there is a DC-DC converter, and then all the DC-DC converters are connected to a DC to AC inverter. And then it is connected to the grid. So this is a converter 1, and this is converter 2, and this is converter 2. So this is single phase multi-string inverter. And here comes the 3-phase multi-string inverter. So here DC-DC, again 3 phases. So multiple DC-DC converters are connected to a major part 3. This is a single phase DC to 3-phase AC, and then it is connected to the utility grid. Then PV topologies. Again, PV inverters with DC-DC converter with or without isolation. Then PV inverters without DC-DC converters with or. So here 2 classification with the DC-DC and without DC-DC. So here comes the set source inverters, where one stage conversion is possible. Set source inverters are nothing but there will be a which will be incorporating the advantages of both the voltage source inverters and the current source inverters. So, which can the output voltage can be obtained with a lower value to a higher value. That is, over a wide range, you can get the output voltage with the help of the set source inverters. When we use the voltage source inverters, the output will be in the buck mode. That is, the output voltage will be lower than the input voltage. Whereas in current source means the output voltage will be output current will be higher than the input current. So with the help of the set source inverters, one stage conversion is possible, and we'll be getting the output over a wide range. And there is an isolation also required, both categories in the both this PV inverters with and without DC-DC converters. Isolation in both categories are required. A transformer can be used for the isolation purpose, which can be placed on either the grid side, that is a lower frequency side, or on the higher frequency side. Now, so while integrating the grid with the renewable energy system, so many factors we have to consider. There are so many challenges also. One is power quality, then power fluctuation. So quality means with the help of this, we are using so many power electronic devices and other circuits. So power quality have to be considered. So many harmonics with the switches are turning on and off. There will be switching stresses, then switching losses, then this will be producing harmonic waveforms. So we need to consider the power quality also. Then power fluctuations. So renewable energy sources itself is a power fluctuating thing, and we need to take care of this power fluctuations also. Then storage. With the help of battery, we can store the power from the renewable energy source, but the cost and complexity has to be considered. Then there are so many protection issues. Then comes the islanding problem. That is, PV plant should be disconnected within 2 seconds of the formation of an unintended island. Otherwise, the whole system will get affected. So then the reconnecting should happen only after the system voltage and frequency are within the prescribed limits. So when after the formation of a or after the islanding happens. So this islanding is a major issue. So we have to take care of all these things. So many researches are going on in these areas also, challenges associated with the grid. grid integration, because so many the renewable energy sources, usage of renewable energy systems are increasing so in a graphical manner, so or exponential manner, and then so the challenges also increases, so researches are going on in this. So if we are planning any research, we can consider these areas also. Then comes the safety considerations, incorporate an anti-islanding function. Then install a lockable switch at an easily accessible position, that is manually isolate the REPS from the grid. Then establish a direct communication channel between the owner and the utility. So suppose we are having in our home also, if we are having a renewable energy source, that is solar panel or something. So always there will be power from the going to the utility. If it is in the online mode. So if anybody comes to, or any repair work is going on the utility side, we have to take care that our power is not going into the utility side. Otherwise, some problem will come. So that we have to consider. That is, install a lockable switch at an easily accessible position, that is manually isolate REPS from the grid. Either it is a domestic consumer or the industrial consumer, there should be a switch so that we can disconnect the REPS if any repair work is going on. Then incorporate an anti-islanding function so that the connection, as mentioned in the previous slide, it will be reconnected only after the voltage and frequency gains the required value. Then establish a direct communication channel between the owner and the utility, so that we can inform. If anything happens, we can inform them directly. Then the protection issues. New fault levels should be accessed due to the connection of the RES. So then facility to isolate REPS from the grid when fault occurs. Then protection facilities against the transients in the grid. Then also voltage and frequency regulators also should be provided. So as the renewable energy sources or usage increases, again also the fault levels, there is a chance of getting faults, different types of faults. So it should be assessed due to the connection of RES. Then whenever there is a fault, then we have to isolate the renewable energy system from the grid so that no complications will be there due to this renewable energy system or power flowing from the renewable energy system to the grid. Then again, against the transients, dV by dt and di by dt protections also should be there when we use the renewable energy system. Then voltage and frequency regulators should also be provided, because from the voltage and these will be variable. Voltage and frequency will be generated from the renewable energy sources will be variable. So we have to control that before feeding the grid system. Or different loads also. If it is a standalone system, then also we some loads like our PC or other small voltage devices, that also we have to protect against the transients and also the voltage and frequency variations. So these are some of the connectivity standards. So PV power plant inverters be capable of maintaining a power factor within the limits of 0.95 lagging to 0.95 leading. Then it should operate in the frequency range of 47.5 to 52 Hertz. Then it should deliver a rated output in the frequency range of 49.5 to 50.5 Hertz. Then it should keep the IEC standard 61000 for flicker and IEEE 519 for harmonics. So this is a. So if any questions are there.
Any questions from participant side?
So if there is no question, then we can mail me also if any clarifications are required.
Okay, ma'am. We will share your mail ID to the participants, ma'am.
Okay.
So shall we wind up, ma'am?
Yes.
On behalf of the Department of Electrical and Electronics Engineering and Sribadi Institute of Management and Technology, I extend a heartfelt gratitude to Dr. Vasanthi V for delivering such an insightful session on recent trends in power electronics for renewable energy system. Ma'am, despite your busy schedule, you graciously accepted our invitation and took the time to share your valuable knowledge and experience with us. Your insightful presentation and practical perspectives have made this session truly enriching and inspiring for all the participants. We sincerely appreciate your support, encouragement, and willingness to be a part of our faculty development program. It has been an honor to have you with us, ma'am. Thank you once again, ma'am.
Okay, thank you so much for giving the chance from Sripati's side. Thank you very much for the coordinators for nicely organizing that DP. Thank you.
Thank you, ma'am.
Participants, the feedback form has been put in the chat box.
As we come to the end of today's FDP, I would like to thank each one of you for your active participation and enthusiastic involvement throughout today's session. We hope the discussion and knowledge shared today have been informative and beneficial to all of you. Before we conclude, I would like to remind all the participants that tomorrow's session will be a hands-on training on PLC. To ensure a smooth learning experience, kindly install the AnyDesk application on your laptop or mobile phone before joining the session, as it will be required during the hands-on activities. We look forward to your enthusiastic participation tomorrow as well. Until then, have a pleasant evening, take care and good night. Thank you.